So, the interpretation of quantum mechanics. We've all enjoyed the technology that's come out of quantum mechanics for a long, long time. This theory has been with us for over 100 years. It was in 1900 sharp that Max Planck came up with the quantum to explain the black body spectrum, and then the Bohr atom followed, and in 1925 and 1926, Schrödinger and Heisenberg gave us the current mathematical, or Schrödinger in particular gave us the Schrödinger equation and the current mathematical formalism. And there's no doubt that there's something very right about this. We use it all the time in our work. But it's also undoubtedly true that there's no consensus on what it really means. Right? Pick out 5 random physicists and ask them to write down on a piece of paper what quantum mechanics really means, and you're not going to get consensus. Even if you find a lot of people who claim to subscribe to the same interpretation of quantum mechanics, and you ask them to write down a definition of what they really mean by that, we'll often end up with 3 different sub-interpretations. So just for fun, first of all, I thought I'd ask what you guys think by asking you a few sneaky questions here. First of all, do you believe, quantum computers will be very exciting if we can make them work. Do you believe that new physics that violates the Schrödinger equation of quantum mechanics is going to make large quantum computers impossible? Yes or no? Who thinks that?
What is the question again?
So the question is whether, to give some background, if the quantum computers only work if the Schrödinger equation works, and if if the Schrödinger equation somehow isn't valid in some circumstances, that could potentially lead to quantum computers just not working, even if you could build them. So the question is, do you think that some kind of new physics which violates the Schrödinger equation of quantum mechanics is going to make them impossible, these computers? Who thinks yes?
And by large, you mean that there exists a sufficiently large size of the Hilbert space so that
Yeah, and with all of my questions, you're allowed to make any interpretation of the question. Make
exactly.
any
under that condition, I vote yes.
make any interpretation of any of my questions that you want, and then answer that. This is all done in good fun and jest. So who thinks yes, it's going to make things impossible? We have 1. Who thinks no? 1, 2, 3, 4, 5.
I think
and who didn't vote? 1, 2, 3, and undecided.
It may make it more
about
possible.
this question.
More
Okay.
possible.
Well, let's get to even these.
And the answer is?
I'll tell you that at the end. What about this one?
The quantum computer will
Do
announce
you believe that all isolated systems actually obey the Schrödinger equation,
I think that
or evolve unitarily, as we sometimes say? Who thinks yes to this? 1,
I'll
2,
vote yes to that one.
4, 5, 6. Who's for no? 1. And who didn't raise their hand? 1, 2, 3. Undecided vote. Steady at 3.
Yeah.
All right.
See, one question is, do isolated systems exist?
That's again a very, very reasonable question to ask. So should we think of everything, for example, as an isolated system, as all of the universe as an isolated system, or not?
How could it become suddenly isolated?
Well, if you, many people would argue that if you take everything that exists, it by definition is isolated because there's nothing out more than it. But we don't need to get into this just to have a little bit of fun with these questions, because here comes an even more tricky one. So, which view of quantum mechanics is closest to your own? Okay, so you're free to interpret any of these in whatever way you want, and just pick the one that makes you feel the most warm and fuzzy. 1, Copenhagen interpretation, including the postulate of explicit wave function collapse when you observe something, or modified dynamics like George Rubini-Weber, for example, for those of you who know what that is, which says that the Schrödinger equation is actually not the real equation, there's another one. Or the many worlds interpretation of Everett, where there is no collapse and you have parallel universes, or consistent history interpretation, or the Bohm interpretation, or the modal interpretation, or the none of the above interpretation. So let's see, who's for Copenhagen right now?
Can I choose multiple choices?
You can
Yeah,
choose
there's
one,
multiple
which can be this one. Or I'll let you vote, spread you get a total of one vote, you can spread it out, superposition. You want to put half on?
I'll put half on Copenhagen.
Okay. And then, anyone else? Oh, what about who's for modified dynamics? Anyone?
I'm not sure I understand these all, but I'll go for that one.
Okay. And what about many worlds? Oh wow. 1, 2, 3, 4, 5. Okay. What about oops. What about the moment? What about system histories? What about Bohm? Bohm interpretation. I thought you had some sympathies for Bohm.
You should read my essay. I have a different.
Okay, I will. It's
He's
on
gonna
my
go for
to-do
number.
list. The modal interpretation.
What is it?
If you don't know, you're not going to learn it. None of the above.
That's
1, 2, 3, and that's your other half. 1, 2, 3. That's 4 and a half. That's a very popular interpretation. Just for the fun of it, let me show you. Okay, one last one. Do you feel comfortable saying that these Everettian parallel universes are actually as real as our universe?
Keyword there being
Andre.
comfortable.
And
Was
you
it
voted
yes?
twice, didn't you? Didn't you vote both
Yeah.
many worlds and none of the above?
Oh, and here I have a split vote.
Okay, that's okay. So who votes yes on the very last question? Melanie, and you're voting 1/2 for this, or
Yeah.
anyone else? I'll vote for that too. So that's 2 and what about no? 1, 2, 3, and undecided. 1, 2, 3, 4. Cool. Let me just for fun show you. I did the same poll at Harvard in the physics department when I gave a talk there back in November, and I was actually kind of shocked by the way they voted. If you look here,
This is the faculty at Harvard?
it was everybody who came to the talk.
So this was a colloquium or a?
It was a seminar that was in the physics department, but there was a lot of people there. There were 42 votes here, you see, and I was kind of stunned. This Copenhagen got 0, and here we got 1/2 vote for Copenhagen. And